Hello, Algebra 1 CP students. Hopefully you're having a great day so far. You may notice it's probably a little dark around me. It's about 8 p.m. here, so it's not going to stop us from doing some math. We can go all night if we need to, but I'll only keep you for about 20 minutes or so. Regardless, I'd like to continue my discussion today on solving and graphing inequalities. You may recall from last class that we talked about how to deal with inequalities of greater than, less than, greater than or equal to, or less than or equal to, where really the solving techniques are the same for working with equations where we have to get that variable alone, but then we just have to represent the set of all possible solutions on a number line. But otherwise, the solving techniques are more or less the same. All right. We didn't do any problems like this in particular, but I think you should be able to look at a graph like that and actually determine the inequality that would result in that graph. It's like going the other direction. So if I look at that graph, we notice that 7 is the focal point of the graph. So obviously 7 is going to be involved somehow. And we are shading everything to the right of 7. So whatever my variable is, we'll call it x for this particular case, has to be greater than 7. And the last thing I notice is that the point on 7 itself is shaded in, meaning that not only is it greater than, but x could be greater than or equal to 7. So I would say the inequality modeled by the graph that you see here is the fact that x is greater than or equal to 7. All right, so that should be a quick little recap of inequalities. Keep in mind that if this were an open circle as opposed to a closed circle, then we would be just strictly greater than, correct? And if it were pointing the other direction, then we'd be talking about less than. All right. So, like I said, we've worked with all those solving techniques the other day. We saw that they were more or less the same as solving regular old equations. But let me hit you with this. You ready? What if I had this example? Negative 2 times x is greater than 10. All right. And I asked you to solve and graph this inequality. Well, you might be like, this is Giorgio. Easy peasy. It's one step. Negative 2 times x. How can I undo that multiplication by negative 2? Well, let's divide by negative 2 on both sides. That means I'm going to get x is greater than negative 5, right? Meaning that any x value greater than negative 5 would satisfy this inequality, right? Wait a minute. Not quite. Think about the actual problem here. Although it looks pretty sound to divide by negative 2 on both sides and just end up with this inequality, if you actually start to plug in some numbers, I don't think this works. Think about negative 4, for example. Negative 4 is greater than negative 5. So if I plug in negative 4 for x, this should result in a true statement, which it does not. Negative 2 times negative 4 is positive 8. Positive 8 is not greater than positive 10. Maybe that's just a bad example. Let's pick another one. How about 5? Positive 5, right? Negative 2 times positive 5 is negative 10, which is also not greater than positive 10. Shucks. Something's definitely going on here. And the thing that's going on here is the fact that we divided by a negative. All right? When we multiply or divide by a negative in an inequality, you notice that it kind of gets a little messed up in the fact that this is no longer a true statement. Plugging in these values no longer satisfies the inequality. In fact, if you notice, it's not satisfying the inequality because it's literally the opposite. If I plug in negative 4, negative 2 times negative 4 is 8. That's not greater than 10. That's less than 10. If I plug in 5, like I said, negative 2 times 5 is negative 10. That's not greater than 10. That's less than 10. So to account for this change, and I'm going to put a big old star here, and I recommend you do the same in your notebook. Put a nice big star, and note that when you multiply or divide both sides of an inequality, not equality, inequality, by a negative number, you need to flip, and I'll put that in quotes, flip the inequality. So when you multiply or divide both sides of an inequality by a negative number, you need to flip the inequality. And what I mean by that is instead of leaving this as this side being greater than this side, we flip it around to account for the fact that we divided by that negative, and now this would hold true because the negative sort of inverts everything. It makes everything the opposite. Notice, if I pick something now less than negative 5, say for example negative 6, negative 2 times negative 6 is positive 12, definitely bigger than positive 10. All right? So that's really the long and short of it, is when you divide or multiply by a negative number, it's going to flip the inequality. If it's greater than, it's going to turn into less than. If it's less than, it turns into greater than. Less than or equal to turns into greater than or equal to. And greater than or equal to, of course, turns back into less than or equal to. Let's take a look at a couple examples of that in action. Ready? Hopefully you understand why, though, because of my examples that I showed you here, it just is weird and it just doesn't work out. The dividing or multiplying by a negative inverts everything, including the inequality. All right, so that's why we have to flip it. It's not like an equation, which is always perfectly balanced. The inequality flips back and forth when you deal with that negative. So consider an example like this. What if I had x divided by negative 2 minus 4 is greater than or equal to negative 7? All right. Well, we would start to solve this in the same way, just as if it were a two-step equation where I would need to get x alone. So first I'm going to add 4 to both sides. No problem in doing that, right? We don't have to do any flipping when we add and subtract. This is going to result in x divided by negative 2 is greater than or equal to negative 7 plus 4, negative 3. Now, how would I get x alone? How would I undo that division by negative 2? I would, of course, multiply by negative 2. But since we're multiplying by a negative value, we need to make sure we switch the sign. This is now going to be x is less than or equal to. See how the inequality flips? Negative 3 times negative 2, positive 6. All right. Which, of course, we would represent on a number line by having 6 be the center of the number line and shading everything to the left of that, including 6 itself. Notice I left that as a closed circle. Okay? So please, it's a very important detail and one that's very easy to overlook. But when you multiply or divide by a negative number, that inequality needs to flip around. All right? Because otherwise, as you saw up here, it's just not true anymore because you negated everything. All right? Let's take a look at a few more examples. How about something like this? If I have negative 2 times x plus 6 plus 4 is greater than 18. All right? A little bit of distribution going on here, but it shouldn't be very scary at this point. We can distribute the negative 2 to both of these terms here, giving us negative 2 times x, which is negative 2x, negative 2 times 6, minus 12, and then plus 4 is greater than 18. Combining like terms over here, negative 12 plus 4 is negative 8, so that's negative 2x minus 8 is greater than 18. Hopefully we can kind of understand combining like terms right now. That should be a pretty solid idea at this point. Now I'm at my two-step inequality. It would be nice for an equation, but we can still deal with it just the same. In order to get x alone, I need to add 8 to isolate the variable term. We get negative 2x is greater than 18 plus 8, which is 26. Now I can divide both sides by negative 2, but again, hold up. Dividing by a negative means that we have to flip that inequality sign. We divide by the negative. This is now going to be x is less than 26 divided by negative 2, negative 13. Okay? And once again, I would represent that on a number line by having negative 13 be the middle point here. It's less than, strictly less than, not less than or equal to, so we're going to have an open circle, and we're going to shade to the left to represent all the values for x that are less than negative 13. All right, hopefully that makes sense. Sink it in a little bit. I certainly hope so. All right. Now, what comes with this idea of multiplying and dividing by a negative is just like with equations, how we sort of gradually ramped up. Of course, we could have inequalities where there's variables on both sides of the inequality, not just one. So let's take a look at what that would look like right now. All right, something like this. Let's do 8 times 5x minus 8 is less than negative 4x plus 24. Okay, something like that. In order to solve this inequality, notice we have variables on both sides, which we'll get to in a minute. But of course, I can clean up this left side first by distributing the 8. We're going to do 8 times 5x is 40x. 8 times negative 8 minus 64. We're going to say that that's less than negative 4x plus 24. And now we have a choice. Now we have a choice to make. What we can do is we can subtract the 40x over to this side to eliminate the 40x, or we can add 4x to both sides to eliminate the minus 4x. Which one do you choose to do? Well, personally, I would be inclined to add the 4x because that would keep everything positive and it would probably be easier to do it that way. But let me show you what happens if you go both ways. We'll start by adding the 4x to both sides. So let's suppose we have 40x minus 64. I'll just rewrite this same line, is less than negative 4x plus 24. Just to show you that you actually get the same thing no matter which choice you make. What if I'm choosing to add the 4x to both sides? We would get 40x plus 4x is 44x. Minus 64 is less than 24. Little bigger numbers than we're generally used to dealing with, but still no problem. It's still 2 steps here where I want to get this term with the variable by itself. So I'm going to start by adding 64. If we add 64 to both sides, we get 44x is less than 88. That's 24 plus 64. We divide both sides by 44, and notice what we get for our inequality. We get x is less than 2. All right. Let's see what happens if we solve it the other way. If we try to solve it the other way, suppose I'm at this same line of 40x minus 64 is less than negative 4x plus 24. And for whatever reason you decide to subtract the 40x from both sides, certainly nothing wrong with that. Again, I probably wouldn't be inclined to do that, but you could. You would get negative 64 is less than negative 44x, right? That's negative 4 minus 40 more is negative 44 plus 24, like that. Now I need to get the x alone. Even though it's on the right side, doesn't mean anything's different. We're going to subtract 24 from both sides. That would give us negative 88 is less than negative 44x. We can divide both sides by negative 44, but watch out. Dividing by that negative means we have to, just like we saw before, flip that inequality. That's going to give us negative 88 divided by negative 44. Positive 2 is greater than x. And if you notice, we really end up with the same equality. X is less than 2, or 2 is greater than x. Those mean the same thing, right? X is definitely smaller than 2 in both cases. So in order to represent that on a number line, you would do it the same. We have x is less than 2, so here's my 2. Open circle because we do not include. And we're going to shade everything to the left. All right? And notice this also covers the case where 2 is greater than x. If you actually wanted to flip this around to make it a little more comfortable, you could certainly write this as x is less than 2. If you notice, as long as the inequality faces the larger value, it's equivalent. Okay? You might be more comfortable writing it that way. Hopefully that makes sense. Let's do another one. Ready? What if I had 8x plus 3 times x plus 5 is greater than or equal to negative 13 plus 7x? Okay. Once again, we have some distribution to do. Again, think of if this were an equation. If this were an equation, hopefully at this point after the last unit, you'd be like, there's a lot of stuff going on, but I can deal with this. I'd first distribute, then try to combine like terms, then try to get all the variables to one side, and then solve. It's the same exact processes with an inequality. I'm going to have 8x plus 3 times x is 3x. 3 times 5 plus 15 is greater than or equal to negative 13 plus 7x. Not going to touch that side yet. We have a couple great like terms over here. 8x plus 3x is 11x. 8 plus 3 plus 15 is greater than or equal to negative 13 plus 7x. Once again, we arrive at a fork in the road. You have a choice as to whether or not you want to subtract 11x from both sides to eliminate this, or subtract 7x from both sides to eliminate the 7. I would be inclined to subtract 7x from both sides because that keeps everything positive. If you notice, I stressed that point when we were dealing with equations to try to keep the coefficient of x positive. And the reason for it was because I knew it would eventually connect to inequalities, where dealing with that negative results in flipping the inequality, and I didn't want anybody to get confused. That's a point where a lot of students generally forget to do that and make a little mistake. But if you actually try to keep everything positive, that actually works out quite nicely. You kind of avoid that negative situation where the inequality flips around. But anyway, if I subtract 7x from both sides, we would get 11x minus 7x is 4x plus 15 is greater than or equal to negative 13. And now we can solve this just like we solved all the others. I would subtract 15 from both sides. We'd say that 4x is greater than or equal to negative 28. Divide both sides by 4 in order to undo that multiplication, and that gives us x is greater than or equal to negative 7. And so, of course, I'm going to graph that on my number line. By having negative 7 be the center of the number line, I'm going to shade it in because it's greater than or equal to, meaning that that definitely includes negative 7 as part of the solution set. And since we're greater, we're going to go on the right side, just like that. Alrighty? So, just a quick little recap before we call it a day. I know we're ending the video a little bit earlier than normal. I generally shoot for 20 minutes, and I think I've gone over by 1 or 2 minutes on like all of my videos. So this is a nice little break that we are in fact ending early. But because we're ending early, more so than ever with this type of stuff, I do really want you to try the practice problems posted on Google Classroom because it'll be really great to actually try some on your own. All right, so just a quick little recap. When we're solving these types of inequalities, it's really the same exact steps that we do for solving equations. But there is one little twist. That twist is the fact that when we multiply or divide both sides of an inequality by a negative number, we have to flip the inequality to make sure that the equation, to make sure that the statement remains true. If we left the inequality the same, as you saw here, the statement would no longer be true because every part of the inequality got inverted. And when you're inverting or switching or taking the opposite of every part of the inequality, we need to take the opposite of the inequality sign itself as well. All right. So once we know that little fact, we can then handle these problems just fine. We just have to keep in mind that inequality flipping right at the end, when you divide or multiply by a negative number. And then we saw over here that when we're now dealing with variables on both sides, it's just like equations where we want to get them all to one side. And notice that that situation can actually come up again if you make the coefficient of x negative in this step when you're moving your variables around, all right, from one side to the other. That's why it's always good to try to make that coefficient positive so you don't have to worry about that flipping like we saw down here. But if you happen to make that coefficient negative, say you decided to go this route to subtract the 40x, it's totally fine as long as you remember to flip the inequality at the very, very end. All right, because otherwise your statement just wouldn't be true anymore. All right, we'll call it a day right there. Thank you so much for your attention and focus, everyone. I really appreciate that. Again, try those practice problems, and I will see you for some practice time tomorrow. And hopefully you'll do some great work on practice on Friday. Take care, everyone.